To determine tenant demand using National Electrical Code, or NEC, demand factors. Firstly, identify the applicable demand factors. For lighting and receptacle loads, refer to NEC Article 220.43. For specific equipment and appliances, refer to the relevant NEC articles. Secondly, calculate the tenant loads. For lighting and receptacles, estimate the connected load in watts for lighting and receptacles using the following formula: load in watts equals lighting load in watts per square foot times area in square feet, plus receptacle load in watts per outlet times the number of outlets. For other equipment, obtain the connected load in watts from the equipment nameplate or manufacturer's specifications. Thirdly, apply the demand factors. Multiply the calculated loads by the applicable demand factors from the NEC. For example, for lighting and receptacle loads in commercial spaces, the demand factor is typically 0.5. Fourthly, sum the tenant demands. Add the demand-adjusted loads for all equipment and appliances in each tenant space. If it is not possible to estimate loads based on connected load calculations, you may need to access each tenant's panel boards and perform the following steps. 1. Identify circuits. Locate the circuits that supply power to various equipment and appliances. 2. Estimate load. Measure the current draw on each circuit using a clamp on ammeter. 3. Calculate demand. Multiply the current draw by the voltage and apply the appropriate demand factor. Assembling a meter gutter load summary involves creating a table. The table should include the tenant, the main breaker size, and the demand in kilowatts. As an example, tenant 1, main breaker size 100 amps, demand 20 kilowatts. Tenant 2, main breaker size 75 amps, demand 15 kilowatts. Tenant 3, main breaker size 50 amps, demand 10 kilowatts. This table will provide you with the data required for the meter gutter load summary. NEC Article 220 provides comprehensive guidelines for calculating branch circuit, feeder, and service loads. Article 220.43 specifically addresses lighting loads for various occupancies. To calculate lighting loads, multiply the floor area by the unit load specified in Table 220.12. For receptacle loads, Article 220.14h provides guidance. Non-dwelling receptacle loads are calculated at 180 volt-amps per outlet. Demand factors from Article 220.42 can then be applied to the general lighting and receptacle loads. These demand factors allow for reductions in the calculated load based on the assumption that not all connected loads will be operating simultaneously. For specific appliances and equipment, refer to the nameplate data for the connected load in volt-amps per watts. Article 430 covers motor loads, and Article 440 covers air conditioning and refrigeration equipment. These articles provide specific rules for calculating the ampacity of conductors and the ratings of overcurrent protection devices. To accurately calculate tenant loads, you will need to gather detailed information about the electrical equipment installed in each tenant space. This includes lighting, receptacles, HVAC systems, and any specialized equipment. Once you have collected this information, you can use the appropriate NEC tables and demand factors to determine the total demand load for each tenant. If accessing tenant panel boards is necessary, it is important to follow proper safety procedures. To energize the panel board before making any measurements, use a calibrated clamp on ammeter to measure the current draw on each circuit. Multiply the current reading by the voltage to determine the volt-amp load. Apply the appropriate demand factor to account for non-continuous loads. Demand factors are percentages that are applied to connected loads to estimate the maximum demand that is likely to occur. The NEC provides demand factors for various types of loads, including lighting, receptacles, and electric heating. These demand factors are based on historical data and engineering judgment. When calculating the meter gutter load summary, be sure to include all of the tenants that are served by the meter gutter. The meter gutter should be sized to accommodate the total demand load of all tenants, with consideration for future expansion. It is also important to ensure that the meter gutter is properly grounded and bonded in accordance with NEC requirements. The calculated load is essential for ensuring the electrical system is safely and adequately sized. The NEC outlines the steps in calculating the load, starting with determining the general lighting load. For general lighting, you'll use table 220.12, which provides unit loads based on occupancy type in volt amps per square foot. Multiply the square footage of the space by the unit load to find the total lighting load. Receptacle outlets are calculated as 180 volt amps per outlet according to 220.49. This applies to non-dwelling units. Add up the total number of receptacle outlets and multiply by 180 volt amps to determine the total receptacle load. For appliances, equipment and other loads, you will need to use the nameplate ratings. The nameplate provides the volt amps or wattage of the equipment, which is essential for accurate load calculations. After calculating the different types of loads, demand factors from NEC 220.42 can be applied. Demand factors allow for a reduction in the overall calculated load, recognizing that not all connected loads are likely to operate simultaneously at their maximum. The specific demand factors vary depending on the type of occupancy and the size of the connected load. After applying demand factors, you need to combine all the loads together. Sum up the lighting load, receptacle load, appliance load, and any other loads after applying applicable demand factors to get the total calculated load for the service or feeder. The calculated load is used to determine the appropriate size of the service conductors, overcurrent protection, and equipment. Using the calculated load ensures that the electrical system can safely handle the expected demand. You may have to access tenant spaces to determine actual electrical loads. When assessing the electrical loads within each tenant space, start by identifying all the circuits and their panelboards. Each circuit should be clearly labeled, indicating what it serves. This step is crucial for organizing and categorizing the loads. For each identified circuit, estimate the connected load. Check the ratings on lighting fixtures, receptacles, and any permanently connected equipment. Record the volt amps or wattage for each item. You may need to open junction boxes or access equipment nameplates to gather this information. In some cases, you might not find a clear rating for a particular load. Use a clamp-on ammeter to measure the actual current draw of the circuit while the loads are operating. This will give you a more accurate estimate of the demand. Once you have estimated the connected load for each circuit, apply demand factors as appropriate. Demand factors are percentages that reduce the total connected load based on the likelihood of all loads operating simultaneously. Refer to NEC Article 220 for the applicable demand factors based on the type of occupancy and the nature of the loads. For example, a demand factor of 50% might be applied to general lighting in a commercial space. After applying demand factors, sum up all the loads for each tenant space. This will give you the total demand load for each tenant, taking into account the diversity of their electrical usage. Compile all the information into a meter gutter load summary. This summary should include the tenant name, the square footage of this space, the estimated connected load, the applicable demand factors, and the total demand load. This summary will provide the building department with a clear and concise overview of the electrical loads in the building. The meter gutter is a critical component of the electrical distribution system, serving as a central point for connecting multiple meters to the main service. Properly sizing the meter gutter is essential to ensure safe and reliable operation of the electrical system. To calculate the required size of the meter gutter, you must first determine the total demand load of all the tenants served by the gutter. This involves summing up the individual demand loads for each tenant, as calculated using the methods described earlier. Once you have determined the total demand load, you must select a meter gutter that is appropriately sized to handle the load. The NEC provides guidelines for sizing meter gutters based on the ampacity of the conductors and the number of conductors in the gutter. In addition to ampacity, you must also consider the physical dimensions of the meter gutter. The gutter must be large enough to accommodate all of the conductors and connections without overcrowding. Overcrowding can lead to overheating and potential fire hazards. When selecting a meter gutter, it is important to choose a product that is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all. This ensures that the meter gutter has been tested and certified to meet applicable safety standards. Installing a meter gutter should be performed by a qualified electrician in accordance with all applicable codes and regulations. The electrician should carefully follow the manufacturer's instructions and ensure that all connections are properly made and torqued. Regular inspection and maintenance of the meter gutter is essential to ensure its continued safe and reliable operation. The inspection should include checking for any signs of damage, corrosion, or overheating. Any issues should be addressed promptly to prevent potential problems. NEC Article 220 provides the requirements for calculating feeder and service loads. Using this article along with information about the loads of each tenant, you will be able to create the load summary that is required. The process involves several key steps. Firstly, determine the general lighting load. Refer to NEC Table 220.12 to find the unit load for the specific occupancy type in volt amps per square foot. Multiply this value by the floor area of the tenant space to calculate the total lighting load. Secondly, calculate the receptacle load. According to NEC 220.14i, each receptacle outlet is typically calculated at 180 volt amps in non-dwelling units. Multiply the total number of receptacles by 180 volt amps. Thirdly, identify and calculate the loads of any specific appliances, equipment, or motors. Use the nameplate ratings on the equipment to determine their volt amps or wattage. For motors, follow the guidelines in NEC Article 430. Fourthly, apply demand factors. Once all the individual loads are calculated, apply the demand factors from NEC 220.42. Demand factors allow for a reduction in the calculated load, since it is unlikely that all loads will operate simultaneously at their maximum. The demand factors vary depending on the occupancy type and the total connected load. Fifthly, sum the loads. Add up all the individual loads after applying the applicable demand factors to determine the total demand load for each tenant. Sixthly, create the load summary. Present the results in a table format, including the tenant name, the calculated lighting load, the receptacle load, the appliance and equipment loads, the demand factors applied, and the total demand load for each tenant. This summary will provide a clear overview of the electrical loads in the building and is essential for sizing the service and feeder conductors and equipment. Accessing tenant panel boards requires you to follow safety procedures and use the correct tools. Safety is the first and most important consideration. Before approaching any electrical panel, ensure you have the appropriate personal protective equipment, including safety glasses, insulated gloves, and appropriate clothing. Never work on live circuits unless absolutely necessary, and always follow lockout-tagout procedures to de-energize the circuit. Next, identify the correct panel board. Refer to building plans or electrical diagrams to locate the panel board that serves the tenant space you are assessing. Verify that you have the correct panel before proceeding. Open the panel board cover carefully, using insulated tools. Inspect the interior of the panel for any signs of damage, such as loose wires, burned components, or corrosion. If you notice any hazardous conditions, do not proceed until they have been addressed by a qualified electrician. Identify each circuit within the panel board and determine what it serves. Refer to the circuit directory or labeling to identify the loads connected to each circuit. If the labeling is unclear or incomplete, you may need to trace the circuits to determine their destinations. Use a clamp on ammeter to measure the current on each circuit while the loads are operating. This will give you an accurate measurement of the actual demand on each circuit. Record the current readings for each circuit along with the corresponding voltage. You can then calculate the volt amps or wattage of each circuit. After collecting the data, apply demand factors as appropriate based on the type of loads and the occupancy of the tenant space. Then, sum up all the loads to determine the total demand for the tenant space. When working in tenant spaces, it is important to be respectful of their property and operations. Coordinate your work with the tenant to minimize disruption and clean up after yourself when you are finished. The meter gutter load summary consolidates all the electrical load information to provide an overview of the building's electrical demand. Begin by collecting the load calculations for each tenant. For each tenant, record the total calculated load in volt amps or kilowatts, taking into account all lighting, receptacles, equipment, and appliances, and applying any applicable demand factors. Summarize the total connected load for the entire building by adding up the individual tenant loads. This will give you the overall electrical demand of the building, which is essential for determining the size of the service equipment and conductors. Include all relevant details about the electrical system, such as the voltage, phase, and frequency. This information is necessary for selecting the appropriate components and ensuring compatibility. Specify the size and type of the main service conductors, as well as the overcurrent protection devices. This information is crucial for verifying that the electrical system is adequately protected against overloads and short circuits. Identify the location of the meter gutter and its ampacity rating. The meter gutter must be sized to accommodate the total load of all the tenants, with sufficient capacity for future expansion. Include any other relevant information, such as the presence of emergency generators, transfer switches, or other special equipment. This will provide a more complete picture of the building's electrical system. Organize the load summary in a clear and concise format, such as a table or spreadsheet. This will make it easy for the building department to review and approve the electrical design. Review the load summary carefully to ensure that all calculations are accurate and that the electrical system complies with all applicable codes and standards. Submit the load summary to the building department for approval, along with any other required documentation. The load calculations are necessary for determining the appropriate size of the electrical service, feeders, and equipment. The NEC requires that the electrical system be designed to safely carry the calculated load. Load calculations help ensure that the system is not overloaded, which could lead to overheating, voltage drop, and potential fire hazards. By accurately determining the electrical loads and applying demand factors, you can optimize the size of the electrical system, saving money on materials and installation costs. An oversized electrical system is not only unnecessary but also less efficient. Load calculations provide valuable information for managing the electrical system and planning for future expansion. By tracking the electrical demand over time, you can identify potential problems and make informed decisions about upgrades and modifications.